Hello, this is Pre-Calc Lesson 70, Percentile and Z-score. This is all from the normal distribution. We talked before about the normal distribution. And quick review, we remember that 68% of the data lies between one standard deviation. 95% of the data lies between two standard deviation, and 98% of the data lies between three standard deviations. Okay, now what we're going to do now is we're going to actually talk about the standard normal table and z-scores and how you calculate standard normal deviation. Okay, so population versus sample, okay, there's different meanings, and this will help you understand kind of what's happening. If we're talking about the population, the mean is mu, okay, we've seen mu before. Sample, the mean is x bar. If you're talking about population as a whole versus just a small sample. Standard deviation, we know, is sigma when we're talking about the population, and it's s sub x when we're talking about a sample. You don't need to know about s sub x, but we will be using x bar, mu, and sigma. Okay. The equation of a normal curve, we have y equals 1 over sigma square root of 2 pi e to the negative 1/2 times x minus mu over sigma squared. You don't need to know this, okay? It's just a fun fact. Another fun fact, the area under this curve is 1, or 100%, you can think about it. It's just, we use the standard normal deviation and the normal curve for lots of things, talking about how a test is distributed, how height is distributed, weight is distributed, and we're going to look at lots and lots of examples of things, but this is where it all comes from. Now, let's talk about z-scores. Okay, what a z-score is, z is x minus mu over sigma. That's the equation that we'll use, okay? What this tells us is instead of getting exact percentages out of our normal curve, we can use the z-score to be able to determine where something lies on the standard normal table, which I'll show you in a second, okay? Now, x is the raw score or number that we're looking at for a particular data set. Mu we know is mean, and sigma is the standard deviation. So basically we're figuring out how does the information that we have relate to the average and standard deviations. Okay, now we figure this out by, see if you can see it. In my book, it's page 442, but right here, this is the standard normal table, okay? The z-score gives you a number on this standard normal table. You find it, and it relates to a percentage, okay? So let me do an example for you, okay? And it will make much more sense, okay? Example 1, so the mean weight, or you could say the average weight of babies for 7 years was 6.8. The average weight of babies when they're born for 7 years was 6.8. And the standard deviation was 0.8 pounds. Okay? Now it will tell you if the distribution is approximately normal. It doesn't matter that you know it's approximately normal because we're not going to be doing any other kind of distribution. Okay, so you can assume that it's a normal distribution. We want to know what percent of babies weighed less than 6.4 pounds. Okay, so we first have to find our z-score. Now we know z is x minus mu over sigma. Okay, the mu we have is 6.8, right? That's our average. And our standard deviation is 0.8. We're looking at the percent of babies that weighed less than 6.4. Now, when you look at a z-score, okay, so I'm going to draw this. Okay, that's my standard normal deviation. My mean is 6.8. I'm looking at 6.4, and I want to know this percentage here, less than 6.4. Okay, when I find my z-score, I get negative 0.5. Okay, now I'm going to look at my table. Make sure you can see that. Might be easier if you look in your book. Now go to your table. We're looking at negative, so I am only looking at these rows. Negative 0 point, right? So I don't have a negative 1 point something, negative 2 point something. I have negative 0 point. And we go over to negative 0.5, and it gives me this value here, 0.3085. Okay, so this relates to 0.3085. This number I got from the standard normal table. Okay. I then take this number and convert it to a percentage. So it gives me 30.85%. And that tells me that 30.85% of babies weighed less than 6.4 pounds. That's my answer. Now, the key to all of this is the weighed less than. When we look at the standard normal distribution and the standard normal table gives us values of the less than. Okay? So we want to know, what if it said, example 2, in the same hospital, what percent of babies weighed more than 7.2 pounds? Okay, more than is different than less than. So let's look at our z-score. So we'll have x minus mu over sigma, which is 7.2 minus my mean, which is 6.8, over my standard deviation, which is 0.8. And this gives me a positive 0.5. So when I go to my table, I go to positive 0.5, and it gives me 0.6915. Okay, this is the number or percent that weighs less than 7.2 pounds. We're looking for more than. So for more than, I do 1, which is 100%, minus 0.6915, which gives me 0.3085, which tells me that 30.85% weighed more than 7.2 pounds. Okay, the table always gives you values of less than. So if you want more than, you do 1 minus. Now, what if we want to know what percent weighed between 6.0 and 7.0 pounds? So if I look at my distribution, okay, this is 6.8, that's my mean. Here is 7 and here is 6. I want to get this value, this percentage in between them. So what you do, okay, is I'm first going to find the z-score for both 6 and 7. So the z-score for 6 will be 6.0 minus 6.8 over 0.8, which gives me a negative 1.0. And the z-score for 7.0 is 7.0 minus 6.8 over 0.8, which if I look, this gives me 0.25. Now I look at my standard normal table. Let's look at negative 1.0. Negative 1.0 gives me 0.1587. So here I'll have 0.1587. And let's look at 0.25. So I have 0.25 is not on my table. So I take 0.2 and 0.3 and I average those two. So I add them together and divide by 2, which gives me 0.5986. So what do these numbers tell me? This number tells me 15.87% are less than 6 pounds and 59.86% are less than 7 pounds. To get the amount between them, I subtract these two. I do 59.86 minus 15.87, which gives me 43.99%. 43.99% are between 6 and 7 pounds. Let's look at this graphically. Okay, if I look here, I have 7 pounds. My z-score for 7 gives me everything less than this, right? So it gives me all of the values in red here that are over here. Okay? For 6, the z-score for 6 gives me all of the values less than over here. So if I do the z-score for 7 minus the z-score for 6, it eliminates this area here, which is what I want. I just want this area in between them. Okay. The z-score is to find the percentage of whatever that falls either less than, greater than, or in between. It could be weights, it could be test scores, it could be amount of food consumed in a day, anything that you can distribute normally. Okay? All right, so we are going to do more with the z-score later, but for now, this is all that you need to know. You really need to memorize this formula. Z-score is x minus mu over sigma. Very important. All right, that is all for now. Have a good night.